Right then. Okay, so um, we are continuing here. So our order point to find this one is expected demand during lead time, then plus the buffer stock. The safety stock. The self stock is just kept for security reason to cushion on demand. So when you have harvested crops, you don't have to finish all of them consuming because you're supposed to wait for tough times to execution for safety stock. So self stock has already been calculated. The demand you expect during lead time. So you need to check for the lead time here. Our lead time is given 12 days. So we know that our daily demand is 30 units. Lead time is 12. So you can actually aggregate. So this one, so meaning our order point, so the order point here is actually going to be, so our order point is actually going to be this demand you expect during lead time, then plus the safety stock of 59.25. Then we can get the amount of the order point, which is the 419. When you calculate this is 419 point, so 419.25. Okay, so 419.25. This is our order point. Okay, so this is actually coming to this amount here for the order point. So what demand you expect during the lead time, then plus a safety stock. That's our order point. Now we can get back to the question here. The other question says the safety stock. Now this one has already been calculated. There's no need to go back to it. So the safety stock has already been calculated. I'm sure it was supposed to be safety stock before the order point, because safety stock is incorporated in the equation for the order point, because the safety stock is found in this one is a part of the order point. So it was supposed to be the safety stock area before the other one. So the safety stock is already calculated, which is this one, 59.25 copies. So it's just a repetition there because it has already been solved. And then we go to the total stocking cost. Okay, so that's our total stocking cost. Now, since there is a safety stock, so we can even simply say this is due to safety, because there is a safety stock. So due to safety stock, so due to SS. So this is our total stocking cost due to safety stock. So since we are in production, we are going to go for this formula here for the total stocking cost, where we simply say our total stocking cost. Let me just put it here as we say our total stocking cost. So that's due to safety is equal to Q over 2. That's the formula to go for. Then P minus D over P, then multiply by C plus D over Q, then multiply by S. So this is the annual carrying cost, this one, and this is annual ordering cost. So we can just substitute. Now here plus safety stock multiplied by carrying cost per unit. Okay, the safety stock we are keeping in the warehouse, safety stock we are reserving at home for security reasons. So carrying cost per unit, carrying cost per unit. Okay, so this one carrying cost per unit. So you can even okay. All right then. So this is what we have. So meaning if you substitute here, so this is the carrying cost. Okay, so carrying cost.
Sorry to.
Yes, please.
I'm sorry. The formula that you have given, where you are saying it's P minus D over P in bracket C plus G over Q. Is it G over Q? Because the first time you explained this, you had said it's D over P. So is it D over P or D over Q?
It is D over Q. Okay.
Thank you.
So here we go. Okay. So okay. So this is it. If you remember, this one is the annual. This one, the first one here is annual carrying cost. Then this one is the annual ordering cost. Okay. So here we're looking at number of orders multiplied by. So this is annual. So this one is called annual setup cost. So this one is annual setup cost. Then here, since there's an aspect of safety stock, so that's why we have included the safety stock here multiplied by the carrying cost per unit. So this is carrying cost per unit. Okay, so now here, this one you can put the amount that we have here, we already know. It's about what? It's one, you can go back here, that's the 1610.15. That's what you put here. So here is 1610.15. Then we divide by 2. Then here we are going to our P is 84. So 84 minus 30. These ones are already computed. Then over our P is 84. Then on our C, carrying cost is already calculated. We found it's a percentage of acquisition cost. So our carrying cost, if you can see here, is the percentage, it's 18% of the unit price. Even from the question was indicated 18% of this amount. So 18% of acquisition cost per unit. That's why they found it 4.95. So you put the 4.95 here. So 4.95. Then plus our D here is 75. So this formula is standard. So this is annual setup cost, which was you are setting up for production. Then over the same 1610.15. So we close the brackets. Then we go for the setup cost. The setup cost has been given here in the question. So you have to check for it. It's a 550. That's the setup cost is 550. So you put the 550 here. So 550. Then plus the safety stock. This is SS, which is safety stock. Excuse me. So now our safety stock is 59.25. So it's 59.25. Then multiply by carrying cost, the cost of carrying the safety stock, because you are keeping the safety stock in the warehouse. So you don't use the unit price, use the carrying cost per unit per year, which is our C, which is 4.95. So use the 4.95, use this one. That's the carrying cost. The cost of holding, the cost, carrying cost and holding cost are the same. So you come and put here 4.95. So this is what goes on. Then from here you can compute. When you compute here, the holding cost here due to safety, so here is this one multiplied by this amount. So 59.25 multiplied by this, they found it 293.287. So this is what's supposed to come here. So 293, you can confirm that. So 293.287, then plus here we can sort out this one. So this one is 75. Those of calculators you can calculate. So 75 divide by 1610.15, then multiply by 550, we are getting 2561.87. So this is it, 2561.87. That's why I mentioned to you that these ones are supposed to be almost the same, because even the first one here, we can compute it. It's giving us almost the same answer. This one, your own time calculator is supposed to calculate it. So if you can check these ones, this one and this one, they are almost the same. Okay. So we are getting again the 2561 point, this one maybe 86. Okay, but so the here we should get almost the same answer for this. So our total stocking cost due to safety, or TSC, so total stocking cost is actually going to be, so we can add those ones. So 2561.86, then multiply by, maybe just say multiply by 2, and plus the 293.287. So we are getting 51. So this is it to be 5417.007. So this is it, the total stocking cost due to safety stock, which is it here, which is almost the same as the just this one. So this is how they got to the total stocking cost. So this wraps up the production model. This is the toughest way a question would come. The same way the question that we're from looking at right now. The other question, the first one we did was too basic, but this one is the toughest way the question would come. This question 4, as we are looking at production model. If there's any question, you can ask me if anyone is behind so far. So we are next, we need to get into our discount model. So unless there are again questions here that people would want to ask so far before we proceed to the last model in inventory management, which is the discount model. And for the discount model, you are supposed to know that this model, they can only give you the discount when you are buying, because they will tell you, suppliers will tell you, as you buy more units of a commodity, they're going to give you a discount. So the more you buy, the more discount they'll give you based on the quantities that you're buying. So we use the formulas for model 1. So model 3, okay, yeah. I just want to find out, are you having class at school right now? Hello?
Oh, MBA General, next class is at 15.
The next class is at what?
MBA General, we're going into class at 16.
We're going for class at 15?
16, 16.
Oh, 16. Okay, so I'm sure we can continue now with the last model, inventory management. So we are getting to the discount model. Okay. Okay, so let's go to the discount model. Okay, so let's go for model 3. So model 3, which is a discount model. So we wrapped up model 2. So we are getting to model 3, which is the discount model. Now, please note that discount model uses the formulas for purchasing model because the firm can only be given discount when they're buying units of the commodity from the suppliers. So that's when they can only be given a discount. So let's get into this example here, because I've mentioned that this one we use the formulas for model 1. Okay. Now this, the only difference is that this one has a range of order quantities. The first model, purchasing model, you're just ordering a single product. You just want to find how many units you can order at a time only. But this one, there are ranges of order quantities. So they'll give you, if you buy from one box of tomatoes to so many boxes, the price will be so much. And should you buy so many units of a commodity, at least the price, they'll give you, okay, the price reduces because you're looking at how many units you're buying. So the more you buy, you want to take advantage of the discount. All right, so we are going to use the same formulas for model 1, but there are rules that are involved here when using those formulas. So we'll talk about those rules as we go. Now, ABZ company has an annual demand of 12,000 units. Okay, so it's an example looking at our ABZ company. So annual demand of 12,000 units. Ordering cost is 200 because we are still buying. So we are still in the ordering phase. And then the current cost is 20% of acquisition cost, which is the unit price. The company has the following ranges of demand. So should you buy from this unit to the first one to that one, you buy this one to the other one. But so you buy one box or one unit to 399 units, the price is 30 kwacha per unit. Then you buy the 400 units to 999 units, the price will be 28.5. Then if you buy 1,000 or more units, it will be 26.5 kwacha per unit, that is. That's a unit price, or which this one is also called the acquisition cost, SC. So it's acquisition cost. So now the question says, so they're saying, determine the order, or determine the optimal order quantity and their associated cost. So the optimal order and the cost which is involved there. So here there are 3 steps that are involved. Okay, so we can get to the solution because we have the annual demand there. Ordering cost is 200, and then the current cost 20% of the unit price. So we can get into the 3 steps that are involved. So there are 3 steps involved in the discount model. Step 1, you find the EOQ for all ranges. So for each range, you find the EOQ. Then you find the TMC, which is the total material cost for each range. And then the last step, we select the range with the smallest total material cost. So we select the range with the smallest total material cost. So this is just about what this model is all about. So you go for the 3 rules of the game, and you get the optimal order quantity, excuse me, that the firm should order. Because what is happening, this is a real life model, because you would want to take advantage of the discount, because you tell people, okay, as I buy one, what's the price? Okay, as I buy so many units, what's the price? So you would want to take advantage of that discount. Now we get to so the quantity is there. Then you find the unit price is 30. The current cost here from here they're saying it's 20% of, so 0.2 is the same as 20%. But 0.2, which is 20 over 100, which is the same as 0.2. Then by the first one is by 30, that's the unit price. You're getting current cost of 6. Because from here it says current cost is 20% of the acquisition cost. All right, then. So we get to this one. The first one, we're getting a 6. The other one, we're getting 5.7, the current cost, the unit. Then this one is 5.3 based on the unit price multiplication. Then the EOQs, we need to find the economic order quantity now. By this one, so for this range, the EOQs that are here in this table, they are calculated below here. So for this range from 1 to 399, EOQ is 2DS. We are still using this formula over C because why? We are still ordering. So it is 2 multiplied by D is 12,000 by our S, which is ordering cost per order, which is 200. The 200 has been given in the question here, so we can look for it. The 200 is here. Then our annual demand is given here. What is just different are the current costs. So current costs for the first model, for the first range, because here the rules of the game are at step 1, we find the EOQ for all ranges. So you're finding the EOQ for range 1, which is this one. After you multiply here, because the current cost was 6 here from the table here. Then the other one was this one as a current cost. Then the other one was this one as the current cost. So you can see 894.427. Now, this one is not feasible. Why is it not feasible? Because this amount that we are ordering now does not fall within this range. Because we can only order one for the first range, saying order only 1 to 399. So this EOQ we have found is not feasible. That's why there's a comment that it's not feasible, because it does not fall within the range of ordering policy, because you're ordering 1 to 399. But what we have found here is actually beyond the range. So that one goes. Now let's go for the second one, 400 to 999. Here, our EOQ 2DS over C, our C is 5.7, because for this range, our current cost is 5.7. So our current cost is 5.7. So this is what we put as the denominator here. So here, what we after finding this one is feasible, because this amount we have found here falls within the range. Okay, so falls within the range. So it is the feasible EOQ. Okay. Now we go to the other one, the last one. The 2DS by that. So we are getting this amount. This one is not feasible because it does not, we are ordering 1,000 or more. So this 951.6617 is not feasible because the minimum we are ordering is 1,000 or more. So this one is too less, it's too few. This one is less. Okay, so this is few. So yeah, so now we have done step 1. You have to find the EOQ for oranges first of all. The second step, we're going to find the total material cost for each range. So we come here, the EOQ not feasible means that the order quantity does not fall in that range. That is what that means here. So it does not fall in that range, so it's not feasible. So whatever you find, you check if it's feasible. So the first one is not feasible because it's actually beyond the range. The other one is feasible because it's within the range, because the 917 is within this interval. Then the other one, this is not feasible because we should order 1,000 or more. Now we get to this one. EOQ, this one does not fall in the range. Okay. And then for this one falls in the range of this one. So when we come to this one, when finding the total material cost, our Q we should use where the feasibility starts from, because this one is not feasible for this range. So this one, this EOQ is not feasible. It's a cross. That's not for this range. So use where you should have started ordering from. So the minimum we should order now, we should go for the lower bound. So use this one as our lower bound to put it in it the equation for the total material cost. Because the second step we are looking at now, we are finding the total material cost. Okay, so total material cost is what we're finding now. So the formula for this total material cost is this one. Okay, so we are still using this total material cost formula for model 1 for the purchasing model. But now our Q we are using for this range, we are using the lower bound because the EOQ of this is not feasible for this range. So this EOQ is this one here, Q. So, but we would have picked it, the 894.43, if it was falling within the range. But since it does not fall within the range, we use this lower bound. So 1, that's why the 1 comes here. Over 2 is constant. Then our C is a carrying cost. So you go back to the carrying cost here. We found the 6 here. That's a C. Then here we get to our D is our annual demand, which is 12,000. Q, we are ordering 1 unit. Our S is 200 from the question. Then the unit price for this one, our unit price for this one is 30, which is acquiring cost per unit is 30. So 30 multiplied by 12,000. So we're getting 360,000. Then here you're getting this amount. Here we are getting a 3. So the total material cost for this range is 2,760,003 kwacha. Okay, so that is for that range. You build up, you go to the second range because we are finding the total material cost for each range. So we're looking at each range, and there are 3 ranges here, 1, 2, 3. So we get to the other one, which is this one. This one falls in the range, so we are going to pick it because it's feasible, this one. So as we come here, we are going to put 917.66 is okay because it's falling within the range. And then the 2 is there. Let's see a carrying cost for this one. You go back and check the carrying cost because we already calculated, which is 5.7. And then we put the D is 12,000 over this by 200, which is the ordering cost. Then this one is the unit price. Our unit price we can check here is 28.5. So 28.5 here multiplied by annual demand of 12,000. Then we are getting the 348 to 30.671. That's the total material cost when you're adding these ones. And for the feasibility, we're getting, okay, so here, this one was supposed to be, guys, this is feasible. This one was supposed to be 917. So 917.66 divided by 2 multiplied by 5.7, which is okay. Then that one 12,000 divided by, okay. Okay, so we are getting these ones were supposed to be, so this one is supposed to be 2, not a 3, 2, 6. Because for the feasibility, I mentioned that these ones are supposed to be almost the same. Since this one is feasible, so it's supposed to be 2, 6, not 3, 6. You can confirm this one supposed to give us this amount, and this one is supposed to give us this amount. If you find for a feasible EOQ, these 2 figures are supposed to be the same. It's supposed to be the same. Okay, these ones. Then we have this other one. So we have gotten this one, the 348 to 30.67. This is the total material cost for this range. Then we go for the last range. So last range, we are getting this. And since the EOQ we found here was how much? It was 951.6619. It was not feasible. 951. Okay, so this one 0.66. So this one is not feasible. So what happens? We should use the lower bound. So, but the lower bound here should be minimum, which is you should put the 1,000. So not feasible. Okay, so what happens here? We should do, so this one is not feasible. So we are going to put the 1000 is what we should do, put here as our Q, even here on this Q. Okay, so we are going, so this is where the 1000 is coming from, and then carrying cost is 5.3. We're getting this one. Since we are just forcing to put getting this one, so the answer is, since we are just, these are not supposed to be the same, okay, because we are using the EOQ which is not feasible. Unless the EOQ that is feasible, that's when the annual carrying cost and ordering cost are supposed to equalize. So here 1000 over 2 by this one, you're getting this one divided by, so this is annual ordering, annual carrying, and then this is the unit price, which is the acquisition cost per unit, then multiplied by our annual demand, which is our this amount. So we are getting this plus that, and then we are getting total material cost is 323,050 kwacha. 323,050 kwacha. So what's our conclusion? We compare this material cost. So we compare this one, this material cost for this range. And then we also compare this material cost for this range. We also compare this material cost for this range. And we should select the smallest possible. According to step 3, we need to select the range with the smallest total material cost, which is it. That is the conclusion here. So as we come here, you can see our conclusion. ABZ company should order 1000 units with the smallest total material cost of this. So this is our conclusion. So meaning we should order 1000 units or more here, order 1000 units or more, because this is the one that is giving us the smallest total material cost of 323,050, because among the three ranges, we have this one for 1,323,050. Then you get to the other one. The other one is 348. This one is 323,050. Then the other one is 348,230.671. And then this other one is 2,076,003. This one is 2 million. It's not in thousand, it's million. 2,760,003 kwacha. Then the other one we're talking about is 348,000. And the other one we're talking about is 323,050. So our conclusion here is that we should order 1,000 units with the smallest total material cost of the stated amount of 323,050 kwacha. So we have looked at model number 1, which is the purchasing model. Purchasing model has no ranges of order quantities. As you can see, this one, the discount model, it has a range, okay, of order quantities. So you can order, they give you a range. So you order from this range to this range, the price is this. This one, you order from this range to this range, the price is this one. Then for the model 1, it is open. There are no ranges of order quantities, but we use the same formulas. So for model 3, for the discount model, you just really need to understand that there are rules or there are steps that you need to follow. Just these ones, so that you understand these 3 steps. When you understand these 3 steps, then well and good, it will be okay with you. Okay, so we need to have time to go through now the question papers from the pamphlet. You can get to a question from the pamphlet. With time, we need to go through the question from the pamphlet. Okay. So for now, I think we can end here, but we need to go through, since I've explained the 3 models, so we need to go through the assignment when we look at the questions, because everything else I've explained. So we need to get to the question. In the next session we are going to have, we need to get to the question from the assignment and from the pamphlet concerning the discount model. I think production model, we've gotten a question from the pamphlet. Also, we need to, for this model 3, we also have to do a question from the assignment or from the pamphlet so that you can understand thoroughly. So it's okay. Are there any questions? Hello?
On my part, I don't know about Gillian.